Hello everybody, today I'll show you how you can make use of the World Partition combined with PCG, so you can vault only assets that are near your player. You do not want to vault your entire open world map all the time, so let's start. First, let's look at the example graph that we had in the previous tutorial, and I'll show you why you want to use loading only of partitions like the World Partition system does. So let's say we have this example city. So if your player is close to the city, but let's say it's here onto this side, you do not need to have your entire city loaded in your map, or even the city loaded at all if you're, for example, here far away from this city in the mountains. So if you want to load this city only if it's needed, one of the ways that you can do it is with the World Partition system, and to combine PCG with the World Partition is very easy. So let's first see an example where it's not using the World Partition. So I'll add a couple of cubes just to show you what the World Partition does, and I'll scale them so they're easier to see. So I'll add these cubes at the four corners of the town, so they're easy to see from far away. That's why I'm making them so huge. And let's say that you start your game, or you end up in your game here close to the entering the city from this side. So if I play the game, you'll see that the cube that is far away from me, so the one in the back right corner, is loaded only when I go close enough to the city. And if I go far away, it disappears, and if I go far away even more to the right side, the left one will disappear too. And this is what the World Partition system is doing for you. It loads and unloads content based on the proximity to the player. And you can see now that the bottom left and right parts are unloaded. So let's say we go here where they are unloaded, and let's create a cube in the sky on which we can stand, so it's easier to demonstrate. So let's add a player start as well. So we are starting on this cube every time that we run the game. And I'll orient it to city. Okay, something like this, and I'll make the cube a little bit bigger so we are sure. So let's hit play. And now that we are running the game, you can see the back cubes that are representing the faraway corners of our city are not loaded, because the World Partition system is making sure that it loads only things near us, but the full city is loaded. And if I go back into the editor by clicking the escape key and select parts of the landscape, this is how the World Partition is splitting your level into different parts, and all the content that is on these different parts will be loaded only when you are near this content. So if I go to the world settings window, and if you don't have it, go to window and here world settings, and it will open this window for you. And here you have the loading range and the cell size to set up. And I have the loading range set up to 52,000, and you can preview the range by clicking this show grid preview. And actually I think I had it to 30,000, something like this. Yeah, so where it's closer to us, so we'll only load parts of our world which are sitting on these partitions. So let's play the game with this 30,000 range right now, and you can see we only have one of the columns loaded because it's the only one that's close enough, and we need to go in the direction of the other ones if we want to load them. So let's run a bit to the front left side of our city, so you can see that it will load the column right there. So here it is. So this system will automatically make sure to load what content you need based on the settings that you have. So let's keep our loading range to 30,000 so it's easier to see what is loaded and what not. And let's go back into our details panel. Let's select our PCG graph, and it was this one using level instances from the previous tutorial example. So the setup is really easy. You need to click just one checkbox. This is partition checkbox here into the details, PCG component, settings, graph instance, and here is partition checkbox. So let's click this checkbox and it will regenerate. And right now, if you select your PCG, you can see that it's split into different parts for every partition of the landscape that you have. So you can see here, this is the landscape partition that we have. And if I select the PCG, it's matching exactly this partition. So let's save it and let's run our game right now. And you will see that only parts of the city that are near our player are loaded. And if you go a little bit closer to the city, like this, it will load the other parts. So make sure that you have your settings dialed in correctly. So you have your city loaded when you are close enough to see it. Basically right now I have too little loading range for a real example. But if your city, if your game, for example, has a very foggy environment and you cannot see the city from this far away, you don't need to load it in your map. So you need to make sure that you set up properly your range, and it will work for everything that World Partition is keeping loaded in or out of the game, not only PCG. But right now we're focusing on the PCG setup. So this is the entire thing you need to change. Just click this PCG partition checkbox, but there are a couple of things that you need to take into consideration when you do this, because it will change a little bit the setup of your PCG graph. So let's go and uncheck this is partitioned, go back into the non-partitioned graph. So I can give you an example of what can be problematic or needs to change how you set up things when you are using partitioning. So let's disable this grid preview to not be in the way. And let's say that when you generate a town like this, you want the town to have some feature, for example, some big monument in the center of the town. So let's go into our PCG graph and let's add create points node. And this create points will create a single point in the center of our town. And this will generate a monument that will stand in the center of our town. And if we want to be always in the center of the town, we cannot use the coordinate space global because it will always be at the 0, 0, 0 position of the map if it's global, not the place that we want to have our town. And let's see the example right now. So let's create an extends modifier for this point so it's easier to see where it is when we debug it. So let's put 100 into each field, or 100 is too little, maybe 1,000. Okay, so 1,000 in every field of the extends modifier, and then create a debug node. So here is the point that we are creating currently, and it's always into the center of the world. So let's make it a little bit bigger in Z direction so it's easier to see. Okay, so this is the point. And if we move our city, the point is always here. This is because it's using the global coordinate, and this is the 0 coordinate of our world, our map right now. And if we want this monument to be in the center of our town, we need to change this coordinate space to local component. In this example where our graph is not partitioned. And you can see that right now I'm always having this monument that we will generate in the center of the city. And this is great, but what will happen if we change our graph to be partitioned? So let's save this graph. Let's go back into the world and let's click the Is Partition checkbox. So immediately after we partitioned our graph, we can see a change that happens. So this monument that we want to generate is, first of all, not in the center of our city. And second of all, it's repeating itself for each partition that our city is covering. So if I move our city right here, you can see that for each partition over each part of the landscape partition that we have, there is such monument place generated. And this is the problem when you use this local component with the partition graph. The partition graph will take as a local component the actual partition of the level. And the partition of the level is with a fixed position for your world. So where your graph, your world is being partitioned by the engine. And that is why it's something like the global space that we have earlier, but for each individual partition of your graph. So this placement will not work for us. We want to have it where we place our town and not where the partition is. So let's go back into our graph now that it's partitioned and change this create points coordinate space instead of local component to original component. And this will not be the local partition, it will be the graph that we actually placed in the world. This is the original component that we placed, this PCG volume that we placed in the world. This is the original component, and now you'll see that when we move the town, this monument is always generated in the center of the town. But there is additional problem right now. If you look down here into the debug objects, you'll see that for each partition we are generating such object. And if we inspect these create points with the A key and select the objects into each partition of our world, you'll see that we are creating a point for each of the partitions. And this is a problem because we are stacking currently 1, 2, 3, 4, 5, 6 points on top of each other into the center of our town. And this is because for this graph is running for each partition, and this create points is creating a point into our original component placed for each partition. If we spawn an object for our monument in the center right here, it will be 6 objects on top of each other. Or if our town is bigger and it covers more partitions, so let's scale a bit our town. So let's change, for example, here into the X direction, let's make it 300 times scaled. So let's open our graph again. And right now, let's force regenerate it. We probably have more partitions. 1, 2, 3, 4, 5. Okay, there are 6 again, but if we move it a bit so it covers more of the map area, or let's scale another direction as well to be sure that we hit more partitions with our town. Let's open it again. Let's regenerate the graph. And now we have more partitions, so even more repeating of our object in the middle. And this is a thing that you need to consider when working with partition graphs, where you are generating your points, and to make sure that you're not overlapping points for each partition, that you will not get the benefit of having a single object. You'll just respawn the same objects on top of each other. So how you can fix this? So let's get the actor data, and the actor data for each component, for each partition, will be referenced by this self filter. So if we are not partitioning the graph, this self will be our PCG volume, but when our graph is partitioned, the self will reference to each individual partition. So if we take a single point for our partition, this will be the full volume of the partition. So we can use an intersection node and intersect our create points with the area of each partition. And then when we connect this to our graph, and let's regenerate and save it, let's inspect the intersection, not the create points. And if we select each separate partition, you see that all partitions but one are having no points inside them created by this create points and then the intersection, because this point on the place of the original component is not falling into the area of the other partitions. It's only into this partition where it's actually placed, and that's why this intersection node is removing it from the other partitions. And this is how you make sure that you don't have points owning on the same place. And similar example will be with create points grid. If we create a grid with, for example, 1000 unit cells, and we have the grid extends to 50,000 into X and Z direction. Let's debug this grid. So it's a huge grid. Let's reduce it a bit to 20,000, something like this. And let's make the cell size in Z 1000 unit as well, so it's easier to see. So here is the grid that we create, and it's currently in the global space. Let's change it to the original component. So we have a grid in the center of our town, and as you remember from before, this will generate the same grid. So if we inspect it, and if we go into each partition will have 1600 points generated for this grid. And this is because all the points of the grid are generated for each partition. But if we do an intersection with our actor data as a single point for each partition, it will look the same. So we can have problems on the intersections. As you can see, we are having some repeating points, and you need to make sure that the size of the points does not extend into two separate grids in order to not have this problem. But just as a quick example right now, let's see for each of the different partitions how this points grid is being generating the points. So let's inspect this intersection, and you can see that here in the first partition we only have 324 points. Into this one we have 48, into this one 100. So it will split the points for each partition that they're sitting into. And if you don't have points in any partition, it will be empty. So for example, this partition has only 16 points. So let's spawn something with these points with static mesh spawner. Let's create a mesh entry, and let's spawn a pillar, this pillar, let's say, and let's scale it a bit. Let's do a transform points and do a scale of 5. So if I select them now, you can see that these columns are in this partition together with the buildings, but these ones are in a separate partition. The intersection node together with the world partition system is making sure that only the objects that fit inside your partition of the world are being generated. And again, this could lead to some problems into the transitioning areas, because you can see that here this the area of this point is big enough to fit into the two partitions, so we are generating points into this partition and as well into the other partition. So let's make the extents of these points smaller with an extents modifier before we generate them, and let's scale the points, for example, to 0.1 size, and let's regenerate right now and see if it helps. So actually we need to do this extents modifier before the intersection, so it's taken into consideration when we are intersecting with our partitions in the world. So you can see right now that we no longer have this row of the columns inside this left partition, so they are properly divided into our partitions because they are not taking this huge area. Right here it's the same, so we are properly separating this partition with this partition based on the size of our points. So these are the things that you need to consider where your points are being generated, and in order to make sure that you don't have your points duplicated on top of each other, you need to make sure that you intersect the generated points with the actual partition that you're generating them into. And for the different samplers that the PCG system gives you, this will automatically happen. So this is how to set up the partitioning of your graph. Let's make sure that always you check if you have duplicating points, and hopefully this will help you to create bigger worlds where you don't run into problems that you cannot vault everything for your map. You need to vault only things that you can see and that you're close to interact with. So hopefully this tutorial helped you understand how to combine the PCG with the world partition, and into the next tutorial I'll show you how you can generate components with PCG on runtime and not even have them saved into your world, so you don't waste memory to store the location of each and every small element on your map, for example each grass blade or something like this, where it's not so important for the map and the gameplay to be saved permanently into your level. You can generate everything on runtime, so it's available in the world when you're close to it, but it's not saved into your map constantly. So look for the next tutorial when it comes out. It will be the hierarchical generation for the PCG graph. And I hope you like this tutorial. You can like the video and subscribe for the channel if you liked it. You can join, and into the higher levels you can watch the tutorials earlier than everybody else and ask your questions and get your answers quicker, so you can continue with your game development. And guys, I'll see you in the next tutorial. Bye.